Welcome. In this video, we'll be looking at differentiating some functions. Let's remember that differentiation is the process of finding derivative of a given function, or we can say it is the rate of change of a function with respect to its variable. Now we have been given the following functions, so we are interested in differentiating them. So the function 1 says, let's make it y equals 2x minus 3 all raised to the power of 3. We are to differentiate this function with respect to x. Looking at this function, we are going to use a rule called chain rule. Basically, that is the rule we use when we have a function that is enclosed in a power greater than 1. Instead of multiplying this function in 3 places as the power says, so that is the rule we use that simplifies things for us. We call that chain rule. And chain rule says the y, the x will be equals to the y, the u, multiplied by the u dx. Then what this rule is saying is that we should turn the value inside the bracket into our u. So we can say u is equals to 2x minus 3. Then we can differentiate this u, that is the u, the x will give us 2. Now that we have been able to differentiate the u dx, which means this function has been turned into y equals to u raised to the power of 3 as a result of our substitution for u here. So we can say we have to differentiate this y with respect to u. Then the y, the u, becomes 3u raised to the power of 2. Now that we have the y, the u, and the u dx, we can then come to finalize our differentiations to say the y, the x will be equals to the y, the u, which is 3u raised to the power of 2 multiplied by the u dx, which is 2. And when we multiply this is 6u raised to the power of 2. Then we have to substitute the value of u back into this. 6 open bracket, our u is 2x minus 3. 2x minus 3 raised to the power of 2. So in this way, we've been able to differentiate this function with respect to x. Done. Let's then look at the second function. The second function says y equals 2x squared open bracket 3x minus 6 close bracket raised to power of 3. So if we look at this, we can say we should multiply what is outside with what is inside the bracket. But this is not directly possible unless we first expand this in expression of its power of 3. And that may be taking a longer process. So in this situation, this is a function that involves two separate functions. That is, function y can be said to be, this is one function, let's call that function u. And the other one, another function here, let's call that function v. That is, this one is function v, while this is function u. So to do this now, this is a product rule function. And the product rule says the y, the x will be equals to v, the u, the x plus u, the v, the x. So that is the rule for function in this manner, being a product function. So let's now do it one by one. For u, we say u is equals to 2x squared. Then we can differentiate u with respect to x, that is the u, the x gives us 4x. We do the same thing for v, which is 3x minus 6 raised to the power of 3. And looking at this, v cannot be easily differentiated like this with respect to x. It follows the pattern of chain rule. And when we look at it, we can easily say we are introducing chain rule to differentiate this, dv dx. Now I'm not going to take this longer process again, but I'm going to use a very short method. Look at this very first function that we differentiated using chain rule. Look at the function, look at the outcome. You can basically say the power here multiplied by the coefficient of x, which is 6, we have it here, then we take 1 from the power. Since these x do not have any power, so it's easy for us, I will use the same way. 3 multiplied by 3, that's 9, then open bracket, 3x minus 6 raised to the power of 2. If you differentiate this function using chain rule with respect to x, this is what we are going to have easily. Assuming that there is a power on this x greater than 1, the shortcut is that we multiply the power by the coefficient, then multiply it by the power here to get us what should be here. So when you come across function like that, that is how you quickly differentiate it. Now we have gotten our du dx, we have gotten our dv dx. So we can then say the function originally, the y, the x can then be equals to v du dx. What is our v? This is our v, and this is du dx. So you are going to multiply this du dx with this v. So we will have 4x, that is our du dx, multiplied by v, which is 3x minus 6 raised to the power of 3, plus what we have here, our u, 2x squared, will be multiplied by dv dx, which is 2x squared to be multiplied by 9 to the bracket of 3x minus 6 raised to power square. So we can finally say the y dx will be 4x open bracket 3x minus 6 close the bracket raised to power 3 plus, we can use this 9 to multiply this one outside, that is 18x squared open bracket 3x minus 6 close the bracket raised to power of 2. So in this, we have successfully differentiated this function with respect to x. If you find this interesting, don't forget to like this video, and as well subscribe to our channel for more interesting tutorials like this. Thank you.